So we've talked about length, area, and volume. We've gone through each of the dimensions up to the third dimension. We saw how each of them are related by the previous dimension. So the third dimension is replications of the second dimension is replications of the first dimension, so on. And we've used them to describe points in space. So length has an x-coordinate, area has x and y, volume has x, y, and z. Friends, amigos, engineers, how you doing? We are back at it at the dimensional analysis playlist, and I know we've done quite a bit so far. We've did some overview, but today I really want to hit home with the length dimension, which is arguably the best dimension, just because it's my favorite dimension. And this entire time we've been talking about dimensions, but we haven't really talked about it in the sense that you might think of it like the first dimension or the second dimension. And now we're finally going to talk about spatial dimensions, okay? So spatial dimensions use length, which is the first dimension. And we're going to be using that to discuss different properties, basically, that we can exploit, basically, with the spatial dimensions, okay? So again, remember that this is perfect if you're in physics, you're like in high school, you're taking freshman physics in college. I think that learning dimensional analysis is extremely important, okay? So basically today, I really want to go over length, area, and volume. So let's talk about length first. Let's talk about the first dimension. Actually, let's start with the zeroth dimension, okay? So what the heck is the zeroth dimension? Let's make a little table. Let's make a little table. Dimension. So the zeroth dimension is just a point. It's just a single dot. The zeroth dimension just denotes a point in space, okay? This might be a point on the coordinate plane, but it has no coordinates. It has no x-coordinate, it has no y-coordinate. But the zeroth dimension is just a single point. And if we have 2 points and connect them in a line like this and this, and connect those two together to form a line, now this is the first dimension. So the first dimension is what is known as length, okay? So length is 2 points with an infinite number of points in between, okay? And this is the first dimension. So what if we have 2 lines like this and like this, and connected these together? Now we have the second dimension. So the first dimension is 2 points connected together by an infinite number of points in between those 2 points. And the second dimension is 2 lines connected together with an infinite number of lines in between. Okay, so there's an infinite number of lines in between. And now this is taking this first dimension, length, and this perpendicular second dimension, and it's multiplying those two together. So we have length times length, and we have length squared, right? So the second dimension is like in video games, right? Mario is jumping across the screen. He's moving in the second dimension, okay? So now I bet you can imagine that if we take 2 of these planes in the second dimension, now we have 2 planes and we're connecting them with an infinite number of planes in between. So you can imagine that I'm putting an infinite number of planes in between. So I'm taking 2 pieces of paper and putting infinite number of pieces of paper in between those 2. And of course, this is the world we live in, the third dimension, okay? So although the second dimension may be something like a video game, it might be like a TV screen, we live in third dimension. Why? Because we have length, width, and height. Even the screen you're looking at, it's in the second dimension, but it's being portrayed to you, and your brain is imagining it in the third dimension, because you can visualize length, width, and height, okay? So each time you have a dimension, you multiply it, right? So you have length times length times length, or length cubed. And as you can see, each time you have a dimension, you take whatever dimension that is, and that is your power. So in the third dimension, it's L to the 3. The second dimension, it's L to the 2. The first dimension, L to the 1, and L to the 0, which is, of course, just 1, and that's why we have a single point. Okay, so noticing that we have an infinite number of whatever is the previous dimension in between, that is very, very important for calculus when we start differentiating and integrating. So, like I said, we have this plane right here. So I hope you can imagine that this is the plane in the background, right? And this is the plane in the foreground. And in between those 2 planes, there's an infinite number of planes in between that. Okay, so those are the three spatial dimensions. And so now, as you can tell, probably, we can start talking about some actual quantities. So length is just length, right? It has an x component, so this is actually going to be length. And it can have an x component, so let's just say this is x. Okay, it's just an x direction. So this is just the x-axis. And now, if we have x multiplied perpendicularly, so this is the x-axis, we multiply it perpendicularly, we're going to have the, that's right, the y-axis. And this will be what? That's right, area. Okay, so this is going to be x comma y. Okay, so you spend all of algebra, you spend all of middle school, all of high school, and the second dimension, and you might touch the third dimension a little bit, but you spend the entire time on the Cartesian plane on two coordinates, the x and the y. And x and y are just arbitrary. They're just used to denote length and width, or width and height. It's two dimensions. And so let's just bring this home again. So we have, this is the x coordinate, this is the y coordinate. And as you've already probably saw, you can take a point in the x and you go here, this might be your x, and you might go a point in the y, and this might be your y, and you form them together to create a single point, and now this is your x, y point in the 2D Cartesian plane. And I bet you can imagine that, now let me redraw my axis in the third dimension. So now this is x, and now y, right? Can you imagine that we're looking down on it now? And ooh, third dimension, z, right? So these axes, they're just going, they're perpendicular to each other. Now this is orthogonal. So although this is called perpendicular, okay, so now we have the x, the y, and the z, the length, the width, and the height. And as you can imagine, we're going to put another point. So I'm going to go horizontally on the x and vertically on the y. I have a point right here. So now this is my point on the xy plane, and I can also give it a height component. And I have to go vertically up like this. So this is my point in the third dimension. Sorry if this is a horrible point. But it has an x component, y component, and a z component. Okay? And namely, what I'm trying to tell you is that we finally have got two volume, which again has an x and a y and a z component. Okay? So now it's getting spacey. Alright, so I think that's all I want to talk about. So we've talked about length, area, and volume. We've gone through each of the dimensions up to the third dimension. We saw how each of them are related by the previous dimension. So the third dimension is replications of the second dimension. The second dimension is replications of the first dimension, so on. And we've used them to describe points in space. So length has an x coordinate, area has x and y, and volume has x, y, and z. You probably already saw this, right? But it's important to realize that, again, there's an infinite number of points at each point in space, which is very, very important for calculus, okay? And as we'll see, we can calculate area, we can calculate volume using integrals. So that's the whole point that I want to recap this. If you haven't seen calculus, don't worry, this is not, we're not going to go over calculus in this playlist, but keep that in mind, because we can use calculus, we can use integrals to calculate area and volume. Alright, hope this helps. I'm going to call it here. Don't forget to share this with your friends, family, and your dog.